السلام عليكم أصدقائي الطلاب. Welcome to Chemistry Online with Mr. Ahmed Sulaiman. Today we are going to continue our lesson about oxidation reduction reaction, the meaning of oxidation and reduction. Continue our redox reaction, means reduction and oxidation reaction, with the covalent compounds. We studied in the previous lecture the ionic compounds like MgS, you remember, or AgNO3 plus Cu. It was related to ionic compounds. Now we are going to study the covalent compounds. Some reactions involving these covalent compounds or molecular compounds, I mean molecules involving not ionic bond but covalent bond. Recall what we studied before about covalent bonds. No losing, no gaining electrons, but partially movement of electrons. Sharing, you remember that? So, the reactions containing molecules like hydrogen plus oxygen yields water vapor or water liquid, whatever. It involves a covalent compounds here. So covalent compound hasn't a complete electron transfer, no, but partially transferring, or we can say sharing. Look at this example. If you have hydrogen, remember that they have electron sharing and equally. Why? Because it has the same charge here and here, so it's nonpolar bond, or we can say the sharing equally here. They have the same strength of attracting electrons, so they are sharing equally. Also for oxygen O2 molecule, okay, electrons here are shared equally as well. So one type of molecules have shared equally. In the case of water, remember that oxygen has higher electronegativity than hydrogen. So what happens here is we cannot say transferring, but partially transferring, or we can say attracted. The electrons are attracted toward oxygen here and here. Why? Because oxygen has higher electronegativity, much more electronegativity than hydrogen. For this reason, we can say what happens to hydrogen here. We cannot say lose, but transfer partially of electrons. Almost like losing. We said before, if an element loses even partially or complete, losing electrons means oxidation. So hydrogen here oxidized. What about oxygen? It gains partially, yes, it undergoes partial gaining, not losing here. So we can say oxygen reduced. So hydrogen is oxidized. If I ask you why, you can say it undergoes a partial loss of electrons, the opposite for oxygen. Let's see this reaction, the same reaction. Hydrogen molecule reacts with oxygen molecules to produce water. Hydrogen here, as I said, oxidized because it loses electrons, so it's reducing agent. Yes. If I ask you why it's reducing agent, you can say because it's oxidized. The opposite for oxygen. Oxygen is reduced. For this reason, it's oxidizing agent. If I ask you, oxygen is oxidizing agent, why? You can answer because it's reduced. So this reaction undergoes the redox reaction. We have different meanings here for oxidation and reduction. If you have an element, molecule, any of them has a complete loss of electrons, losing electrons, even in an ionic reaction, okay, it's oxidation. But if it's not ionic compound or reaction, but what happened is shifting electrons away from the atom, it means the molecule in covalent bond. If it shifts the electron, like lose or partially losing, it means oxidation as well. And we said before, you remember, gaining oxygen means oxidation, losing hydrogen in the covalent compound means oxidation, or increase the oxidation number. How? Look here. Look, look at this reaction. Hydrogen here has zero charge, and oxygen has zero charge. They are molecules. What about water here? Hydrogen is positive 1 and oxygen is negative 2. What happens to hydrogen here? The oxidation number increases from 0 to positive 1. If the oxidation number increases, it means oxidized. Oxygen was 0 and becomes negative 2. What happens here? The oxidation number decreases, so it's reduced. It means if something has oxidation number, substance I mean, decreases, it means reduced, and this substance at this moment, oxidizing agent, as we said, okay? Hydrogen here oxidized. Why? Because the oxidation number increases, so it's reducing agent, as we said before. This is new meaning for oxidation and reduction. So increase in oxidation number means oxidation. The opposite for reduction, if it has a complete gain of electrons, it's reduction. If it shifts the electron toward an atom, it's a reduction. Loss of oxygen is a reduction, or gaining hydrogen is a reduction, and also decrease in the oxidation number is a reduction. We have different meanings of reduction as well. You can use any of them. The element that donates electrons in the redox reaction is called reducing agent. We know that because it donates, يعني losing. Oxidized, يعني reducing agent. Yes. Which is always true about reducing agent? I just answer now. It's oxidized. Yes. This is answer. Now we have something called corrosion. If you have iron corrodes by being oxidized, you know, it's oxidized by oxygen, it changes into ion of iron in a compound. It means if you have iron, Fe, changes into iron oxide, for example, Fe2O3, iron 3 oxide. Here, the iron is an ion of iron, yes, and it's positive 3 in this case. It was 0. What happens here? The oxidation number increases, so oxidized. Yes, oxidized. It doesn't happen without existing of some helper compounds or molecules to accelerate the corrosion, like water. Water can accelerate the rate of corrosion. It makes it very fast. And also existing of salts or acids, they make the corrosion more rapidly as well. We have like this reaction. Look, if you have iron element, in the case of solid, reacts with oxygen in the air in the presence of water, it accelerates the corrosion, and it forms iron 2 hydroxide. If you have iron 2 hydroxide and still in the presence of oxygen with water vapor in the air or any kind of water in any case, you have iron 3 oxide still oxidized. Iron still oxidized here more and more. So the presence of salts, acids, or even water accelerate the corrosion. Why? If the question now, why in the presence of salt and acid or even water, it makes like corrosion very fast. Why? Because it conducts the solution very fast and it allows the electrons to transfer easily. So conductive solution here make the electron transferring easier, so it makes the corrosion rapidly. Look at this example. Corrosion of some kinds of metal like copper here. Copper in the building. They put some copper in the building sometimes to make it beautiful. Why? Because copper reacts with oxygen in the presence of water vapor or carbon dioxide and other substance to form this green substance on a layer of copper. We call this layer patina. Patina is consisting of pale green film like this. This compound of patina called basic copper to carbonate. It makes the copper in the building more beautiful. Not all metals corrode easily. It's not easy. Some elements resist corrosion, like gold, like platinum. For this reason, they are very expensive. Why they resist the corrosion and they don't corrode easily? Because they are noble metals, not active. If I ask you why, you can say because they are very resistant to losing their electrons. We have other metals lose electrons easily. Type. What can we do? We need to protect them from corrosion because it loses electrons easily. What can we do? Yes, you can do something. You can protect them from extensive corrosion by coating them. Prevent the oxygen and water vapor to enter by coating them. Coating them by what? By any substance. Look at this first. If you have iron here, this is iron. But look, the layer here easily penetrated by oxygen and water. Why? Because the atoms are not tightly packed together. So some of oxygen and water can penetrate the atoms of iron and cause corrosion. Water here and air can penetrate the coating and attack the iron metal beneath it. But in the case of aluminum, for example, aluminum oxidizes, yes, quickly, and it forms a coating, yes, but the coating here, look, without any space or chance to penetrate. It means this coating layer protect the aluminum atoms beneath it from penetrating this layer. So this metal is protective. Look at the water here. cannot penetrate. Look at oxygen here, cannot penetrate. So for this reason, we can use this layer to protect aluminum, which is reacting aluminum with oxygen and forming this coating layer. Why? Because they are very tightly packed, different from iron here. And we can say aluminum can resist rust more than iron. How can we control this corrosion for the elements like iron, for example? To prevent corrosion, first we can make coating. I said coating by what? By oil, to prevent water and oxygen to penetrate, by coating by paint, some paints, by plastic, by any other metal, even by any kind of this we can coat the metal to prevent water and air and prevent corrosion. Type. The second method to control corrosion is sacrification. What is sacrification? One metal is called sacrifice. Sacrificed element is an element more active than the element I need to save, and it allowed to corrode or to save the second one from corrosion. How? For example, if you want to protect iron in a bridge, for example, or engine or like this, we can put another element like magnesium, which is more active than iron, a piece of magnesium or zinc or like this, and place it in electrical contact with iron. Why? Magnesium here is sacrificed the iron. When water and oxygen attack the iron, what happens to the iron? Remember, it loses electrons. Yes. And iron begins to be oxidized. Yes. Then magnesium also is losing electrons and compensate the electrons lost from iron, because magnesium is better reducing agent than iron. It's more active. So magnesium immediately transfers the electrons to iron atom and prevent this iron from oxidation, so iron doesn't oxidize. Look like this. We have piece of zinc here. This piece of zinc attached to the hull of a ship made of iron. This is made of iron. To protect the iron from corrosion, we put just a piece of zinc to sacrifice and prevent the corrosion of the hull of the ship. This is the second method for protecting the metals from corrosion. And this is the other part of our list today. Thank you, Shabab.